All right, folks, we are going to continue on today with our work with functions, and we are going to do a little more work with equations as functions. So yesterday we learned that an equation like y equals 2x plus 3 is a function. That equation can act as a function. This y is our output. The x that we see is our input. And then this 2x plus 3 that we see right here, this is our function rule. And what that rule does is it tells us how x's and y's are going to get connected. So this says that if you want to know the output, do 2 times whatever the input is and add 3. So the output will be 2 times the input plus 3. That's what that rule tells us. And so we learned yesterday that we could make a function table for this equation, and we can put our x's on one side and our y's on the other. So here in this column we can choose some x's. So I could decide I want x to be a -1. I could decide I want x to be 0. I could decide that I want x to be 5. I can choose anything I want. And then once we pick some of these x values, then we can use our function equation to help us figure out the y values. So first, I will input a -1 for the x in this function equation. So that would give me y equals 2 times a -1 plus 3. And we'll do what this says and get an output. So first, we'll do 2 times -1, which is -2. And then we'll add -2 plus 3, which is 1. So we end up with y equal to 1. So -1 and 1 are connected by this function. All right, so next we'll use an input of 0 for x. So we'll put 0 in for x. So that'll give us y equals 2 times 0 plus 3. And again, we'll do what that says. First, we'll do 2 times 0, which is 0. And then we'll add 0 plus 3, which is 3. So we get a y value or an output of 3. So 0 and 3 are connected by this function. And so then finally, we'll take the 5 and input it for the x, which will give us y equals 2 times 5 plus 3. Doing what this says, we'll do 2 times 5, which is 10. Get 10 plus 3, and then we'll add 10 plus 3 and get an output of 13. So this function connects 5 to 13. So this is what we did yesterday. Equations are functions because equations will allow you to connect x's to y's. Now, what we're going to do today is take this one step further. And we are going to talk about function notation. Function notation. And the first thing I want you to understand about this is it doesn't change the way we do things. This is going to be a different way to write a function equation. So this is just going to be a different way to write it. It won't change the way we do things. So the big thing we need to do is make sure you understand this different way of writing that function equation. All right, now, function notation hinges or depends on this statement that I've just written on the board. And right now, that's not going to make a whole lot of sense to you. But we're going to fix that. Okay, so here's the deal. Here's what this is saying. That f tells me that a function named f, so the f tells me that a function named f takes an input of x and produces an output of y. So listen again as I go through this. A function named f takes an input named x and produces an output named y. And if you'll think about it, that makes a tremendous amount of sense because that's exactly what we did over here. This function took an input of x and produced for me an output of y. So this way of writing things makes a lot of sense in terms of how we know a function works. A function named f will take an input of x and give us an output of y. All right, so to kind of stress what we've said here, that f is the name of the function. It's not a variable. It's not a variable. It is a letter that is the name of the function. That x that you're seeing inside the parentheses is your input. That's what you are putting into the function. And that y is the output. It is the answer that that function gives you back. So a function named f takes an input named x and produces an output named y. Now, how do you say this? There are a couple of different ways you can read what I have written over here. The first one is the more complicated. A function of x equals y. This would be one way that I could read this statement over here. A function of x equals y. Or, and this is the shorter way, we can just say f of x equals y. And this second way is the way that I would prefer you read it. So f of x equals y. F of x equals y is the way that we would read that. But here is the important thing that I want you to notice about this statement that we have over here on the board. When we see that symbol right there, when we see that equal sign, then what we're saying is that what we see on this side is exactly the same as what we see on this side. So these two are the same, which means that one can replace the other. If you were sitting here in the classroom with me, and you had 4 quarters laying on your desk, and I walked over to your desk and I took those 4 quarters from you and laid $1 down, you wouldn't be too upset with me because I took your 4 quarters away, but I put something down on your desk that was equal in value. That's how this is. This f of x and this y are the same thing. It's like 4 quarters and $1. So what that means is we can exchange one for the other. We can exchange one for the other in any problem. So, Let me show you how this affects what we're doing. Okay, let's let y equals 2x plus 3. There's my function equation. Since I now know that f of x is the same thing as y, that means that I should be able to go right here where this y is, and I should be able to replace that y with f of x. So f of x is equal to 2x plus 3 would be exactly the same problem. Since f of x and y are the same thing, this y can be replaced with f of x, and that's the same problem. So now let's look at this. This says f of x is equal to 2 times x plus 3. All right, so here's what I need to know. This f is still the name of my function. This x is my input. And this 2x plus 3 that I see over here is my function rule that finds the output for me. So that f is the name of the function, that x is the input, and this 2 times x plus 3 is my function rule that finds the output. So I would read this as f of x is equal to 2 times x plus 3. A function of x is equal to 2 times x plus 3. All right, so now let me show you the way they're going to write these problems, okay? They're going to say to you f of x is equal to 2 times x plus 3. And then they're going to say something to you like find f of 4. Find f of 4. Now, don't make this complicated. This is not complicated at all. What I need you to notice is this said that a function of x is equal to 2 times x plus 3. And I want you to notice that this x in the parentheses is your input. When it says to find f of 4, that 4 is my input. So if a function of x is equal to 2 times x plus 3, a function of 4 is going to be 2 times 4 plus 3. So all they're asking me to do is take this 4 that I see right here and put it in place of that x. Plug it into the function. And then we'll do what it says. So we'll do 2 times 4 first, which is 8. Plus 3, and then we'll do 8 plus 3, which is 11. 11 would be the answer for f of 4, and I want to emphasize that this is an output. That is an output. So 4 was my input, 11 was my output. So folks, this would be just like making that function table like you did yesterday. You don't need to write this down, but I'm doing it to show you here. This would be like having a 4 in that x column, and then working it out and putting that 11 in the y column. You're doing the same thing you did yesterday. Plugging in a number for x, working it out and getting a y. The only difference is the way that it's written. So a function of x is equal to 2 times x plus 3. This x is your input. When they say find f of 4, a function of 4, you're going to plug in 4 everywhere you see an x. This is just input, output, putting a number in for x and getting an answer for y. All right, so let's let a function of x, f of x, equal 5x minus 1. And let's find f of a negative 3. So if a function of x is equal to 5 times x minus 1, a function of negative 3 is going to equal 5 times negative 3 minus 1. I'm going to take this negative 3 that I see right here, and I'm going to input that for x right there. And then I just do what the function equation says. First, I'll do 5 times negative 3, which is negative 15, minus 1. And when I do negative 15 minus 1, I get negative 16. So negative 16 would be my answer. So this is just putting a number in for x, so don't let it confuse you. Let's say they let a function of x equal 3x plus 5. And they say to you, find f of 0. So a function of x is equal to 3 times x plus 5, so a function of 0 would be 3 times 0 plus 5. They just want me to input 0 for x. And then I'll do what this says. This says to do 3 times 0, which is 0, and then 0 plus 5 is 5. So I want you to notice the math you're being asked to do here is simple. All they want you to do is take the number inside the parentheses and input it for the x. Now, let me show you one last thing. Let's let f of x equal 4x, so a function of x equal 4x. Let's let g of x equal 3x minus 1. Let's let h of x equal 2x plus 5. And let's let p of x equal x minus 10. Now, here's the reason that I'm doing this. And I want you to notice how I read these. F of x is equal to 4x. G of x is equal to 3x minus 1. H of x is equal to 2x plus 5. P of x is equal to x minus 10. What I need for you to remember is whatever that letter right there is, it is the name of your function. So I want you to notice that right here on the board right now I have 4 functions. I have used a different letter for every single one of them so that they all have a different name. So, instead of f of x, you can put any letter in front of that you want, and it just serves as the name. So, why would I do that? Well, I would do that because now that would enable me to give you problems that look like this. Find g of 2. Now, here's what this is saying. Listen carefully. Look at this and make sure you understand what it's saying. When it says to find g of 2, that means use the function named g. Use the function named g. So I'm using this one. And I'm going to input a 2 for his x. So use the function named g and input a 2 where you see that x. So for this problem, I would do 3 times 2 minus 1. So that letter tells me which one of these 4 functions I'm supposed to be using. So I would do 3 times 2 first, which is 6. And then 6 minus 1 is 5. So g of 2 would be 5. All right, now let's say I wanted p of negative 1. P of negative 1. So that means use the function named p, which is this one, and input negative 1 for the x. So I'm going to put negative 1 right there where x is. So I'm going to do negative 1 minus 10. And if I do negative 1 minus 10, I get negative 11 as my answer. So notice, if I use different letters, then it makes knowing which function to use a little easier. Okay, I could do find f of -5. Now, this letter right here tells me to use the function named f, which is this first one, and to input a -5 where that x is. So I'm going to do 4 times -5, which is -20. So I want you to notice here, all you're doing is plugging in a number for x. The letter right here in front tells you which function you're plugging into, which function to use. All right, so I could say find h of 3. So use the function named h, which is this guy, and input a 3 for that x. So you're going to do 2 times 3 plus 5. You'll do 2 times 3 first and get 6, and then 6 plus 5 is 11. All right, so that is function notation. The letter tells you the name of the function, so that tells you which of these problems to use. The number in the parentheses is what you are going to input for x. All right, so I want you to give these a try today. If anything doesn't make sense, if you have any questions, then please contact me. Please send me a quick email and let me know. Look forward to seeing your work.